Ladies and gentlemen, welcome to FOBtv, the future of business, where we explore the forces shaping tomorrow. I'm your host, Kevin Benedict. I'm a lecturer and futurist here at TCS, and I want to welcome all of you to the show today. Now, to make sense of the evolving landscape of automotive manufacturing today, I'm joined by expert Subhash Sakorikar. He's the Global Head of Industry Excellence Manufacturing Business Group at Tata Consultancy Services. Welcome to the show, Subhash.
Hey, thank you. Thank you, Kevin. Thanks a lot. I'm happy to be on this show.
All right. So where are you calling in from today?
Right from the heart of automotive, city of Detroit. That's where I lived and made my career for the last 15 years being around here.
Oh, that's awesome. So let's jump right into the hot topic of the day, the status of where we are with automotive manufacturing and with AI and automation, robotics and all that. So let me just start out by saying, why does it feel like automotive advancements have been quite gradual over the last 5 years? We look back at all the hype, and it seems like the hype is taking its time. What's going on out there, Subhash?
Right. So I think, as you said, that as it seems like, right? So that is the true case. So in reality, the adoption of AI and the advancement of in automotive through AI are tremendous and phenomenal. We just don't realize that in the same time and fashion because we are used to see that in the iPhones and a lot of technical gadgets, right? Car is a complex thing, right? It is the complex supply chain. Everything needs to come together. That's why you see that it is coming at a gradual pace, right? Or gradual pace rather. So more importantly, even the ecosystem that supports this, unlike phones and gadgets which are in the pockets or in the bags, these machines run on the roads, right? And the entire infrastructure, whether it is for AI to sense the signals, AI to sense the roads, AI to sense the traffic, everything takes time, right? To build and work autonomously. So yes, but if you look at what has been cooking in the kitchen, it has been at a very super fast pace as the advancements and the innovations that have taken place in automotive ever since, right? For example, just the change of the powertrain, right? Right from IC engines, we ran for many, many decades, right? And now we are changing to electrification with the amount of things going on for battery, for the types of motors, right? And the variety of devices that control the current car are inside the hood is completely different. Mm-hmm. And that is a good pace. That can be expedited for sure, but I wouldn't say that it has been so lame or so slow, right?
So when are we going to visually start seeing it on the road?
Yeah. In fact, we have started seeing it on the roads. It's just that sometimes the roads are not ready, right, to take all of these, right? So you will see more of it when the entire infrastructure in terms of charging, in terms of the placing the roads, placing the signboards, everything is graduating faster. You will see more and more of these. Now, having said that, the real dream of the automotive is on the fully autonomous car, right, which is self-driving, self-healing, self-caring, and all of this, right? So that is something which is speeding up, but it's still some time to see, maybe 3 years or 5 years, right? But it is
5 years. There he
future.
Goes.
Yep.
All right. He's getting brave with that. That's awesome. So if we look back over the last 10 years, Subhash, and what's changed the most? You've been there. What has really changed from 10 years ago to today?
Right. Yeah. So I think looking back in the rear view mirror for 10 years is big changes, right? As I mentioned, that inside the hood of the car, pretty much everything that you see is changed. You see a lot of vehicles which are now electrified or electrification driven. So there were 10 years back, we never had the electrified cars, right? Electric cars. Today, a good population, at least in the United States, is a decent 15% of the new cars sold are on the electrified cars. So that has changed. In the rest of the world, it is much more and pragmatic. So that's in Europe, it's the share maybe around 40 to 50%. In China, it is exceeding around 70% of the cars, things like those. So it is varying in different proportions. But last 10 years have given rise to the change of the powertrain. That is the first big change. Second is the impact of the software in the vehicle. The amount of controls, amount of sensors in a car today, 10 years, it has changed very well. We used to have 20 or 50 sensors in a car. Today, you can easily estimate around more than 300 sensors. Wow. Sensing different parameters in the car. So it's kind of a mini computer walking on the road, right?
So Subhash, my Tundra, Toyota Tundra has 13 cameras on it.
Look at this, right? So that's the stage. So the camera, and each of the camera is not only giving you the view, but they are also sensors of something, right? There are different types built into that. They can sense the weather, they can sense the objects, and so on and so forth, and make you feel you are sitting in a big computer inside.
So Subhash, we hear a lot about smart factories. We've been hearing that for some time. What makes a factory smart, and what does that look like for us that are, uninitiated?
Right. So I think, as the word says, anything you call it is smart when you have intelligence built into it, right? So more intelligence built, more smarter it is. So for a smart factory, it has three major components. The first one is the connectivity, which is the connected plants, connected workers, connected factory, connected robots, so on and so forth, right? And then you have the systems that govern those connectedness, right, which is the control. So controls in terms of autonomous physical AI and things like those, right? And then the third piece is the overall process automation that is taking place. There is less of human, more of processes which are automated. So the smart factories can actually sense the troubles that are coming in, or can self-heal at times, that course correct, let's say slow down certain processes, increase certain processes, change some ingredients, change the workflows and things like those autonomously. So that's what the smart factory would look like.
And what role does digital twins play in that whole smart factory concept?
Yeah. So digital twins, by definition, are the first twins, and then I call them as digital, right? Mm-hmm. So they are the replica of a process or a equipment or a whole plant in itself. So you can simulate the real-time environment digitally. So that's why I call them as a digital twin. Now, if you foresee or simulate certain things, you can do that much ahead of time without actually experimenting on the factory floor. For example, if you got a new car coming in or a new product coming on the assembly line, and if you want to check whether certain components will foul with anything else, right, or they will get damaged, or is the workflow timing going to be smooth, all that you can do much ahead of time in the digital twin without actually physically experimenting. So for a real and smart factory to work faster, if you do that with the digital twin before, it is much more smooth and much more productive in that sense. The second piece is the digital twins have evolved into a kind of control mechanism for the real life thing. So you actually control in advance the digital part of this, and then you will see the actual physical twin getting controlled with the parameters and assembly line throughputs and all of that much ahead of time. So it plays the dual role, one for the simulation and second for the actual actuation of the parameters that you are setting up for.
So I remember the days when it was simple Internet of Things sensors feeding a spreadsheet. So all you are doing is getting cells full of data, and you didn't have the simulation capabilities built into it at that point, and you didn't have the visualization and graphics and all that stuff brought into it. So today, boy, there's a lot of progress there. So we've also seen a lot of automotive robots, probably for over a decade now, haven't we?
Yeah, probably 2 decades. In fact, some of the factories are around 40 years old where the robots were there. But the robots, as we call them as today, which are not mechanically or pneumatically controlled, but more of the hydraulic or electrical controls with much, much more precision, definitely for a decade being around now.
So how do you think that's going to continue to evolve over the next 10 years? What's it going to look like?
Yeah. So it's going to look like more of the current future. Immediate future would be we call this cobots, which is cohabitant robots along with humans. They can work together, they can assist and do certain tasks that are either humanly impossible or better than humans, right? In terms of accuracy, speed, and time to get through. In the future, we foresee, and that is not very distant future, it is almost there types. the robots working in tandem with each other. They are talking to each other. The present day, most of the robots are in isolation. They are caged in most of the times that, okay, you do this job and you don't sense, so because that atmosphere, that surrounding is built for operating for the robots.
Mm-hmm.
Now today, those robots can sense humans, they can sense objects, and they cannot fall with each other. They can pick up not from the defined coordinates, but by sensing where the part is, right? So even if the part is not there, a little bit here and there, they can sense and pick up in the right position. So that is a little big leap on that. Now, if they were to work in tandem with each other, that is meaning in each other's areas, sometimes complementing one robot to the other, that is the complete automation we are currently looking at, very close to be achieving it. And then what it will give towards the future is a completely kind of lights out factory, right? So you have no humans. You can completely, we call them as a dark factories, that you can actually switch off the lights and then run the full factory autonomously, because everything can be sensed and robots can pretty much do that, right from putting the parts inside the factory till the time the final product comes out.
So there's a lot of questions about that. Is that feasible? Is that desirable? Do you really anticipate that, or do you see more of a cobot environment where you have both humans and robots side by side? Which
Yeah.
do you think is more likely?
Yeah, so I think it will certainly depends on the types of products, right?
Mm.
But if you say in the automotive, and if you break down the automotive into some components and subcomponents, so there are factories that assemble the tires or tires to the rims, for example, completely lights out. No need of any human intervention. It picks up the right tire, it picks up the right rim, and assembles and takes it out. Similarly, bearings, for example, I saw one of the big bearing manufacturer factory where there are 220 robots which are operating without a single human being, including the forklifts. They are completely autonomous, right?
Oh,
And
wow.
then they shift the material, they keep it at the right place, they stack it properly, unstack it properly. It's kind of six people operating around 220 robots, and
And
most of the robots are completely. So it's a very height of automation that we have seen. It varies from different products. Now there are certain custom areas where a lot of fine tuning is required. Some artistry is also required. Let's say the seat leathering. If you have a very customized car and a premium leather seats, now that artisan work can't
yeah.
be robotized. So you still need for that. So depending on what component in the automotive you're talking about, the automation levels would differ. But a lot of things have progressed to that. And it's not about avoiding the humans or replacing humans with the machines, right? Just because the labor is costly. No, that's not the philosophy. The point which is driving this is how fast, how productively, how accurately, and how sustainably you can make the products, right? So, for example, even the if you have to reduce the waste, the robots which can do the calculations very proficiently, very fast in the layout optimization, where to cut the things from, is better to be done by robots than the humans. So it's not about the replacement alone, but looking at the efficiency of the overall ecosystem that counts.
Understood. So one of the major costs of most factories is energy. And I mean, when you look at the energy consumed by these factories, are there cleaner and cheaper sources of energy that are going to be introduced or already available? Or what do you see in that area? Is there room for improvement?
Yeah, I think though this particular topic is slightly beyond the automotive manufacturing because this energy applies to every single industry that consumes it. But yeah, the renewables sources are increasingly becoming popular for powering the factories. We are not seeing the factories which are like gas turbine powered or things. Yes, there are as the electricity, which is the primary energy source, is coming through. All the alternative sources of energy that are coming to the grid are actually helping this cause as well.
So let's kind of envision what all this automation is going to produce for us. Walk us through what does it really look like when you have the latest in AI, the latest in robots, the latest in sensors, automation, the best sources of data, when it all comes together in one building. Walk us through what that would really look like and how is that different from today?
Yeah, I think if you look at the full value chain of the automotive manufacturing, right from the product design and development to the supply chain to the production and assembly of those, and then the distribution and aftermarket side. Each of the value chain has a distinct role of AI and automation. For example, in the case of product development, you can do a complete model-based systems engineering way of doing the product development much faster, better, and cheaper today, right? So that way you can reduce the product launch time, which is typically around 18 months to around 36 months for a typical car, and bring it down by half, right? Or the modifications that happen in over 1 year time, you can bring it on 6 months. So you have typically have the upgrade cycles of every year, model year. Like in the US, at least we are used to call it, hey, I own a 2016 Chevy and so on and so forth. How about saying that I own an H1 2016 or H1 2025, H2 2000, like this model. So the upgrades can start coming in much faster and better, right?
So then the question will be, what upgrade version are you on?
Yeah, and it will be much more better because, and that's where the role of AI. It's like the phone upgrades. You sleep over the night, and then
Yeah.
when you wake up in the morning, the your phone is different, right?
Yeah, you'll really have a computer on wheels, right? Is that what they call software-defined vehicles?
Yeah, pretty much that. So that you can have those upgrades. Once the upgrade comes, the car is completed. But there is a limitation, right? Like in the phones, you can only go from this iOS to that grade, and after that, your hardware needs to be updated. The only challenge is the development of hardware takes a little more time than the development of the software,
Yeah.
and the implementation of hardware change is much more complex than the implementation of a software change. So, and I call them as a PLM, which is product lifecycle management, and ALM, which is application lifecycle management. So this PLM and ALM to be in sync is very, very important in the automotive industry. So once you have a software defined vehicle, you need to keep these two developments in sync. At what point of time you are going to call it that this is enough? Now, no more software upgrades on this particular model year, and then you have to have the hardware upgrades, and then you can have the next software upgrade. So that kind of thing you can. We still don't see in the cars as of today. I mean, barring a few Teslas and a couple of advanced other cars, most of the cars are not that fast upgrade. But we'll see very soon that every 6 months you have a complete new model year change. Now, is there a need to do that? Yes, there will always be a demand for improvement, and it has been there, but it will be much more faster because things and the surroundings, the environment with which the drivers drive will change. And once it comes to the autonomous driving, once it is on the road, then the pace of development will be even much more faster because the expectations would start keeping changing, right? The ownership patterns will change, the insurance will change, the new amount of packaging will change. So I can just see the exponential changes that will happen once you have a platform that delivers the autonomous car.
So when I'm listening to you, I can see, okay, we have hardware on one hand, we have software on another, but there's the potential for a wide ecosystem that can contribute to those as well, I imagine. Let me give you a scenario. Tell me, how far do you think we're off from this and what it would take? Imagine cars that can learn which intersections or roads are historically dangerous and accident prone. How might that data impact and influence the way the vehicle behaves on that road? Can that vehicle, Subhash, become hyper aware because of past data on that road, that intersection, potential pedestrian issues, bike issues, other car issues? What do you think?
Yeah, so absolutely. I think one of the biggest parameters, and particularly in the autonomous world, would be different from today is on those roads and the turns where the accidents happen, it is not the same driver every time.
Right.
It is the next driver who has not learned from the previous driver. Now, in the case of autonomous cars, the next driver is actually learning from the past driver. So, because you have continuous learning happening on that driver itself, and not only that driver, but these software is exchanging the information from each other with each other, right? And these software platforms are also changing the information with each other. The chances of committing the same error are much, much more less. One, because it is the same person, same driver, technical driver, same software which is driving on that road, which has learned from the past. And
Yes.
second, it is implementing and the navigation, how to navigate that every time it fine tunes. So that is the main difference that will come in. And I still believe that the most safest world would be with the autonomous driving. There are a lot of things which is yet to be done, but the if the software learns the behaviors and patterns, it will be much better learning than a human, because each time the next driver, as I said, that each time the driver is different. Here, each time the driver is same.
Yes.
Right.
Another thing we read a lot about, Subhash, is circular manufacturing. Is that becoming more common? Is that just a marketing phrase, or are you seeing real attention paid to those kinds of issues on the manufacturing floor?
Yeah, I think I would say both. It is definitely a marketing, but why? Because anybody would market when it relates to the sentiments and some philosophy which is prevailing in the society that will buy, right? So I wouldn't say that it is a fake marketing kind of thing, right? You are not doing it. If the consumers are sensitive about recycling, about the sustainability of this planet Earth, they would eventually buy the products which are sustainable and which are made sustainably. And that's why this marketing and this comes into picture. So I don't separate them in my mind, because you will market what the consumers value. The good point is, as the consumers value more and more for the overall sustainability of the products and its manufacturing, this is becoming more prevalent. For example, today we call them as the 4 Rs, right? Which is reduce, reuse, recycle, and recover, right? Which is the fourth R, which is added now. And that recovery would mean that once the product is out of use, how much of it you can reuse or recover from that failed product. It is not about reuse, but it's the recovery from the failed products or the obsolete products that can be used for the next products. So this has given to the concepts of design for circularity, as we call them. The circular economy is very, very important. People design the products with the next thing in mind, that okay, once this is out of use, how much we can reduce the waste, how much can be can you design let's say a bonnet or a shell, a metal shell, which is least consuming the metal, right? So you reduce the importance. Can you look at the alternate materials, right? Can you look at the flexible materials? So there is a lot of innovation which is happening on the materials front to save the core metals from the planet Earth as well, right?
So,
And car is very complex. It has everything on the earth and minerals that you can imagine. It has in it, right? That is the beauty of the car. Yeah.
So initially, will cars be more expensive because their parts have been built to be part of a circular manufacturing environment or economy there? Or will that reduce the cost because the cost of that part can be spread, or the cost of the material in that part can be spread over multiple products? What happens initially? How's the economics work there?
Yeah. So I think there is always a trade-off of using a new material versus minimizing the usage of it. The final driver, definitely cost is one big consideration, but the final driver is the lifetime value of the things that you are doing. That over a period of, let's say, 10 years, 15 years of usage of this product, what will be the net cost? And that also has to come down, because it adds up. Even if it is an efficiency at one end and inefficiency at another end, the whole chain actually adds up the value, right? So you can't minimize, as I say, that the strength of the chain lies in the weakest link, right? So it's the same philosophy. If you have lots of the parts which are on the face of it are made with the circular economy, and then some of them you don't have, your overall product is still not sustainable, right? So people look at the overall life cycle view rather than one particular unit cost view.
So everything we've talked about here, from digital twins to smart factories, to ecosystems, to autonomous vehicles, the one thing that, or at least one thing they have it all in common, is that there's a lot of connectivity, a lot of interconnection. That must mean there's an enhanced level of attention that needs to be spent on cyber security because of the risk of all those different connections. Where are you seeing, how's that area evolving? Because it seems, I mean, we read about it every day. I read about it today in the paper about the automobiles manufacturers who've been impacted, their production lines have been impacted by cyber attacks. Talk to us about that. What's happening there?
Yeah. So it's very much real. I think one of the things, because of the connectivity issues that you have, that one attack, whether it is with the malware or with some different intentions, whatever could be the reason, it can bring down the factory in a few seconds.
Mm-hmm.
And in such a way that it can disrupt your flow, it can disrupt your ERP systems, MES systems, and bring down the whole thing that you can't even assemble the new cars and figure out days. Recently, for another automotive manufacturer, there was a cyber attack and the production was halted for 65 days, right? And not because the plants were not running or the machines were not equipped, no. Or there was some intention of fleecing or the monetary motives. The important thing, it corrupted the very much ecosystem or the systems within the plant and outside which actually run. For example, imagine a car is coming and then you have a blue rear view mirror on a red car. Right. I mean, if your systems are disturbed, even if nothing is disturbed on the plant, factory is still intact. But if just the sequencing and scheduling of those components goes for a toss, you still can't make the cars, right?
Wow.
So you will never imagine the amount of damage that these attacks can do on the plant. Also, not only on the plant, but also on the systems which are not in the plant, but are supporting from somewhere in the cloud. So it is very much real. People can, there will be ransomware, there will be malware, there will be different types of things. A very, very real threat. And a lot of companies are currently investing heavily on securing these because, again, the trade-off between whether we expose the system through the connected versus what is the risk. So if you are able to safeguard your plant and your systems, it is worth it to go digital and fully interconnected way because the productivity gains are much higher compared to having a non-connected plant there.
So finally, talk to us about what this factory will look like, an automotive factory will look like in, let's say, 2035, 10 years from now. How are things going to be different, Subhash?
Yeah, I think I would say that it would be like, see nothing, hear nothing, but still have everything, right? So if I call them as lights off factory, fully autonomous, self-healing, self-controlled, running on its own, churning out the vehicles with the raw materials as the input as a full autonomous body. I mean, that's the plant we are seeing. At the same time, we can see the flexible manufacturing. That means not in this autonomous setup, not producing the same thing again and again, but on the same assembly line, making different pieces of cars, making different brands of the cars on the same place, right? So the flexible manufacturing with full automation is the world that we are very closely about to see that.
I can imagine a factory, Subhash, that you just switch the software program and they start making bicycles. You switch the program and it's making wheelbarrows. You switch the program, it's making an electric vehicle. Because training, there's no time needed for training of those tools, right? They can just adjust, put on different components and take different inputs, right?
Yeah, absolutely. I think there would be I wouldn't say that cars and bikes can be assembled on the same line, but certainly, even if you're able to make different types of cars and different types of bikes on that line, even that's a big productivity gain, actually.
Wow. Well, I just want to thank you so much for sharing your insight and wisdom with all of us. And for you watching out there, if you've enjoyed today's conversation, please subscribe, share, and join us for more episodes. Thank you very much.
Thank you. Thank you.